Okay, I am picking up where the last video left off. I'm doing a programming video. I'm currently uploading my last one. So there's my pride flag as I had it at the end of the last video, my desktop background, which is just amazing. Okay, what I'm going to do this time is a little bit different. Now, okay, I can access my Windows system from Linux. There's a project that I started on Windows that I want to copy over to Linux. So as I have these things, so we're gonna go to other, and yeah, see, I had my chased image on Windows, but the updated version I just showed on Linux. This was the old version had some major differences, but we're gonna go to SDL blank. Now SDL blank, what we're gonna do with this now, this file isn't really gonna be used exactly. Um, but I mean, not currently. I'm gonna still copy it over, but this is what I use to compile things on Windows. But I'm still gonna copy it over. So here's what we're gonna do is we're gonna go SDL blank. Now, SDL blank is basically a blank program. I mean, it's a program that does something, but the purpose of this program, okay, we're gonna copy this folder. We're gonna take it over here. Now, notice that everything I've been doing is in 0 SDL. The reason it's named 0 SDL is because of the alphabetical order, it goes to the top of the list in the folder because it starts with a 0. So that's literally the only reason it's 0 SDL. Because I have an older SDL project, which I'm going to show. Yeah, this is fun. If I type make here, oh, isn't that cool? That's, you got to admit, that's pretty cool. I had done some really weird stuff with that, but it's an older program that doesn't really apply. And let me make sure that I am recording. Yes, I am recording. Good. Okay. So here's what we're gonna do is I'm going to yeah. So we have go to 0 SDL. So SDL blank. Now technically, because I tend to do SDL chased blank, um, I tend to chase. I don't know if I need to do chased in this or if I just do SDL blank. Um, well, for now, let's have it just be SDL blank. That's what it'll be called. Okay, so we're gonna remove this exe uh, file because it was compiled on Windows. We're not gonna use that. Okay, so what we're gonna do is we're gonna open a terminal here. Now we have two files. Technically, that one file isn't used. That's a batch file from Windows. But wait, oh, there's no make file. Okay, I have to use a make file on Linux here. Well, I don't have to, but it makes it easier. So what we're gonna do is I'm just gonna copy the make file over from chasetrist2. That's what we're gonna do. SDL blank. Okay. So because this is the compiling command that I use on Linux. Actually, I don't even use these. We don't even need this extra stuff because I don't statically link SDL. This is leftovers from an older program. It doesn't hurt anything, but we only need one. And the reason it's named Unix is because Linux is a type of Unix, but I like the word Unix because it starts with U, like unicorn. That's just the name of the rule. So we have our make file here, and then so now we have our make file. I just type make. So this is a very simple program. So SDL, the title is SDL program. Yep. So yep, there we go. It just makes a big pink window. So technically it's magenta. SDL program compiled correctly. It displays that message that it's compiled correctly, and it just works. So main, yep, it works. This 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 SDL blank program, it has only one purpose: to make sure that it's working. Now, I could have just had it create a window. I could have had it do that, but we are actually make it draw. See, this is where the color of it. If I take out the fill rect example, okay, yeah, let's do make. So when I comment it out, it leaves the window as blank. Okay, so that's good. But normally we want to make sure it's really working. We like to have some color here, and of course I can change the color. Check this out. then it's green. Okay, it's totally green. Okay, so here's what we're gonna do. I'm going to I'm gonna leave that. Okay, so there we have it's an SDL program. It works. I'm going somewhere with this. I'm going to show you exactly how it works, but I just love doing make, and I love seeing how fast it compiles and runs. So here is a very basic example. I tried to get the entire example to all fit on one page, which was actually a little bit of work. Sure, if I had taken out some error checking code and condensed some lines, I could have done it, but I wanted to make sure that it was still readable. So this is one way to write a program. So we have global variables, we have the loop. You've seen that in my previous video and other examples. I have a loop variable to control, and it basically, when you run it, and if I press the X, it will close, and if I press the escape key, it closes. So this is all just the loop to keep the window from disappearing. So and it uses only the SDL base library. It doesn't use SDL image, anything fancy. So it creates a window, stores it as a global window variable, and if it's null, oh, interesting. Interestingly enough, there's a problem. I don't have the init code. Let's look up. Let's While this video is uploading, let's see here. I have some files uploading. Okay, so SDL init. Okay, we're gonna look up SDL init. Okay, so return 0 on success or negative error code on failure. Okay, SDL init simply forwards to calling SDL init subsystem. Therefore, the two may be used interchangeably. Though for readability of your code, SDL underscore init subsystem might be preferred. The file IO, for example, SDL reference file, blah 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 blah, are initialized by default. Message boxes also tend to work without initializing the video subsystem. In hopes of being useful in showing an error dialog when SDL init fails, you must specifically initialize the other subsystems if you use them in your application. So flags may be any of the following or together. So yeah, video, yeah, and this initiates the event subsystem, obviously. So the video is important. Yeah, init video. Yep. Okay, so even though the program works without initializing the video, you're supposed to do it. So I'm going to add it. So okay, so I'm going to take it from my previous videos program, SDLJC image. So we're just going to, okay, yeah, init video. So now, and usually, usually we don't run into any problems, but it's going to call SDL init SDL video. It's going to do all of that stuff. So now, okay, so it does everything properly. It does the proper way of things. Okay, sorry, I was just thinking. I sometimes stop to think about what I'm going to say next. So and technically, even though the window and SDL will be just quit when the program ends, I still do the functions to free the memory, shut down the systems, because it's the official right way to do things, and it would make sense in a larger program that might, and it might use SDL, then it might close SDL, but the program might still be running. So yeah, and then yeah, see this, yeah, SDL chased image, yeah, this is still here, yeah, from the, yeah, in that folder. I did not mean to open that. Okay, let's go back. So cat main.c. So yeah, we have this whole program here. So anyway, the program works. It displays a pink, I'll call it pink, window here. But there's more than one way to initialize this. Okay, well, the initialization code is going to stay the same, but we're going to go back to the SDL blank folder. So that is one way. So here's what I'm going to do. Actually, what I'm going to do here is we're going to split this into two branches. We're going to delete this file, and then we're going to create a new folder, and it's going to be, one is going to be surface, because it's going to use the surface. Okay. Okay, then we're going to copy these files to the surface. Now, it uses an SDL surface. We're going to close this. Okay. So it works, but we're going to have another one called renderer. Okay, and you're going to see why it's going to be called a renderer soon. Okay, so the program hasn't been changed. This is merely a copy. So here it works the same, but what we're actually going to do is we're going to modify this just a little bit. So what I'm going to do is I'm going to open this program. What we're going to do is we're going to comment out surface. We're going to comment it out, and so we're removing the surface. So because there's a new feature. So yeah, surface is undeclared. What we're going to do is I'm going to copy code from the renderer. Actually, I'll show you something. So what we're going to do is we're going to comment out, see the parts of the code that reference the surface, we're going to delete. We're gonna comment these out for now. So if we remove those parts, okay, yeah, we're gonna get rid of this comment here. So I've commented out the parts that reference the surface. And instead of drawing to a surface, we're going to create a renderer. What you see here, technically this is the most basic program that doesn't draw anything, but we are going to want to draw a rectangle to fill the screen. So what we're actually going to do, we're going to copy from my SDL Chase 2. So because the initialization code, I already have it perfected. So we're going to do, technically I don't need to have these things initialized to null. So what we're going to do here is we're going to, after the window variable, we're going to have a renderer. And I'm just going to have it be a renderer. I don't have to set it to null specifically. So far, the program still works correctly. But here we are going to do something here. There is no actual surface in this Chase 2. See, I updated from one version of Chase to the newer version using the renderer. So what we're going to do here is the window creation code is basically the same. We don't need to do any changes when it comes to the window creation and all that. But what we are going to do is we're going to do renderer. Yeah, we're going to create a renderer. So instead of getting the surface, of the window, we're going to create a renderer attached to the global variable that's attached to the window. So far, we have no problem. The program still compiles, but it doesn't display anything. It doesn't display anything at all. Okay, so what we're going to do here is, okay, so let's see here. Okay, rect. Okay, let's see here. Rect. So what we want to do is we want to go to a different file. So render fill rect. Okay, so render fill rect. Here's what we're going to do. We're going to do render fill rect. Okay. So what we're going to do here is we are going to draw to the entire window. So just as with SDL fill rect that you do null, in this case we're going to use a null rectangle to render to the entire screen. And let's see here. Okay, actually we still have to set the draw color. It's a bit weird, so we're going to do SDL set render draw color, because we have to set what color are we going to be drawing here. So what we're going to do is we're going to do 0 for the red and green, and then we're going to do 255, and then the final number is alpha, by the way. Now, even though I have the code right, it's still not doing anything. And that's because there's one very important thing we need to do. Okay, after we do the render fill rect, we have to do render present. This is basically the same as update window surface was in the previous code. So this, so this, instead of this, we're going to have this. Okay, render present. Okay. It works. Okay, it works. And see, I wrote all that from my own knowledge, but copying it from the previous program. So what you'll see here is that we can now remove this code referencing the surface. So here we have, so it works. So let's remove the surface. Now, you may wonder, what's the difference between a renderer and a surface? Well, see, in the old version of the code, okay, first I'm going to do a little bit of review here. So I'm going to close out this terminal. I'm going to show exactly how it works. Actually, let's see what's, oh yeah, that was about the init. Okay, so then what I'm going to do is we're going to go to SDL blank. Okay, so in the original one, we're going to look at what we did. So surface was just a pointer to a surface. But what we actually did is we created the window, and then we set the surface equal to the window surface. We get the surface for that particular window. And then it fills a rectangle to the entire window using a null rectangle. You have to look at the documentation to understand that. And then it updates the window surface. So that's the way that program works. So, so this one, when we go here and we type make, it does our pink screen there. So it works. And you don't really see a difference in much of a case here. But with the second method, with the renderer, we're doing something different. It works. It totally works the same, except I have the color different, obviously, which is kind of nice, actually. I think I'll leave the colors different just so that I know which example I'm compiling, because if they were identical completely, it would mess things up. But just to show you, for the sake of example of a change in color, let's actually, okay, let's try this. see, if I do this, there's going to be too few arguments because we have to set the final number, which is 255 for the alpha. Red, green, blue, alpha. And it works. It totally works. Though it actually what happens if we just do 25? Yeah, we're gonna still do 255, but anyway. And then see, we can also do things like we can make it yellow. Set render draw color. Yep, we can make it yellow. Yeah. But anyway, I like to set it back to green because I just like green. Okay. So what we have going on here okay, so but it works the basic same way except it's using a render. We're creating a render and attaching it to the window. Now the SDL create renderer thing is kind of strange because to understand SDL create render, we'd have to look at the documentation. I'll just show you. So SDL create renderer. So what we're going to do here is we're just going to do a search SDL create render, and then we're going to find this. So the flags, it's set to 0. You can have 0 as the flags, you could have different flags, but basically the reason it's number 1 is because a -1 initializes the first supporting driver supporting the requested flags. And the flags, there's different flags here. You can have SDL renderer software, accelerated, blah blah blah. But if you give no flags, it gives priority to SDL renderer accelerated renderers. So in other words, just setting -1 is a safe bet. Now, yeah, so SDL create renderer. So this a renderer is sort of like a graphics context, like an OpenGL, and obviously it works. Obviously this program works and does exactly what it's expected to do. So I have working blank programs. Now you may wonder, why would I use a surface in some programs and why would I use a renderer in another? Well, there's a really big reason for that actually. I'm going to okay SDL blank. Okay, I'm just going to do because I to keep up with my yeah, I'm gonna do SDL chase blank. I'm gonna be using these in the future, and I tend to set up myself a private repository before I upload it to GitHub. I'll probably do that after the video. I'm going to show you an example. Well, why would you use let's see here. Here is a very odd one. Actually, let's see. Now this was weird because I had done something really crazy. This one, okay, I had created a render. Now the reason that you want to use a renderer is because when you use a renderer, you can use textures and you can do some really bizarre stuff. So, for example, oh, let's see, did I make any changes? Yeah. Oh, wait. Oh, close that. Yeah, okay, because it was still open in the editor even though I'd renamed it. Okay, anyway, so I'm going to show you an example here. We're going to go here, and you see that? You see that example? That, my friends, is why you use a renderer, because a renderer can do some really amazing things. So SDL chase triangle, you can do some bizarre examples, and there are many different types of examples. Um, but like let's say if we set this to be 8, then weird stuff is going to happen. Okay, you got to admit that's pretty cool. Now you might be wondering, how does a renderer um, allow you to do stuff like that? Well, obviously there's some fancy code behind it, because there's a lot of stuff going on here. But there are some really good examples. So I started working on my own library. Um, it's kind of weird how this is, but there are some amazing things that you can do. And then here, if I uncomment this code out, then you see not only does it change colors, but now it also spins. Now the the big now notice how it says SDL render geometry. That's because you need a renderer to use SDL render geometry. Okay, so let me show you an example of, well, let me show you how this works. So the renderer is just really good. It's really, really good. So well, here, this is my rainbow text file that does some weird stuff there. There's a lot of bizarre things going on there. Yeah, actually, let me see here. Yeah, there's some very bizarre stuff. But if you want to do like, this is the file. Well, actually, here's Chase the Rainbow Triangle. Here's the header file. So here is a function. Here is a function that actually draws a triangle. Now this sets the triangle color. But in order to to create a filled triangle, you have to have vertices. Now vertices are actually a global array here that I have set here. This is some complicated stuff, but let's see, where are my vertices? Okay, chase polygon. Okay, yeah, that's strange. Yeah, chase. Yeah, chase polygon. Yeah, that's strange. Wait a minute. Yeah, yeah. Where's? Oh yeah, chase the rainbow triangle. So, yeah. So obviously the vertices is actually defined here. So we have a global variable named vertices that's actually defined here. So it's an SDL vertex. Now SDL vertex is one of the newer types added. Technically this array is bigger than it needs to be. But basically it uses various fields from the vertices here. And each vertices, as you can see here, like well, I'll show you an example here. So let me go back to the other file. So each vertice, there's three of them. They're numbered 0, 1, and 2. Each vertice has, or vertex, each vertex has a color. It has the position of x and y. It has other things like texture coordinates that I don't use in this example. But here's the idea. When I do fill triangle, and I put in all these float values, what it's actually going to do here is it's going to set the vertices in their position for the x and y, and it's going to set the color based on the last call to set tricolor, because tricolor is a global variable, so it sets the color. So you might wonder, fill triangle rainbow. Well, it's very, very bizarre. um, okay, let me look at this example here. So you'll notice that it's calling the yeah, fill triangle rainbow regular. So what it's actually doing is it's doing a regular polygon. This is a function that draws a regular polygon, and it does a lot of complicated stuff. So what it actually does, so let's try running this program. So what it's doing here, when it draws the polygon, is it is going through, based on the number of polygon points, um, it will go through each individual thing, um, and it will attempt to draw a triangle. It's actually very, very bizarre. So it sets up the three colors based off of the triangle color. It's I don't quite remember how this all worked. I wrote it. Um, so then what it's gonna do is wait that oh yeah oh yeah so oh I see how it is. Yeah, so that was a different one. To get a better example here, um, okay, let's do another example. What we're going to do here is instead of doing that one, I'm going to show, yeah, so that doesn't draw anything, but let's use this. This is because the regular triangle function is a little bit complicated, but this is just a regular triangle. It's a right angled triangle, but that's an example of how it does stuff. It's changing the colors while it does it. It's actually super cool. But anyway, yeah, we're just gonna. So yeah, so I'm trying to explain it because it's complicated. I kind of understand the basics of how it works. So what it's doing here is it is so for the regular, it's going first it gets the polygon points. Now the polygon points function is actually defined in this header file. It's crazy. See, I made my own polygon structure that has its own color. It has the radius, the radians of the rotation, the center x and y location, the number of sides. So this is all my own code. This is some stuff I did a long time ago. And so it has a function that gets the points of a regular polygon using sine and cosine. But here's the thing is, bottom line is in order to yeah, so the polygon, so this is one of my older examples. It's going to yeah. So chase polygon, draw a star. So this one does some really weird stuff. In fact, I'm going to show you, and instead of messing with the rainbow triangle stuff, we're going to go with a simpler example. We're going to go with chase polygon, draw star. So there is a plain white hexagon. Just plain white hexagon. That's a lot simpler to understand. But what we're going to actually do is we're going to change it into a 5-pointed star. The main polygon sides is 5, the main polygon step is 2. So we're going to, so now we have a spinning star. Now the reason this is essential, I'm going to show you, this is why a renderer is essential. So let's go here. So chase polygon, draw star. So first it set the color of the vertices equal to the main polygon color. And then, it's going to be using those vertices, then it goes to the polygon sides. So each one, it's going to set up 3 vertices. One vertices is going to be at the position of the current corner. Another one is going to be the position of the next corner going clockwise. And then the third one is going to be the center position. So each time what it actually does is it sets up the vertices, sets up the colors and the vertices to draw a series of triangles. And then once it sets up those 3 vertices, it renders that triangle using SDL render geometry. And this only works if you're using a renderer. So you have to use a renderer if you want to draw a triangle. While there may be built-in rectangle filling functions without using a renderer, if you want to draw a triangle, you have to use SDL render geometry. And obviously you can see that it works. It does indeed work. But to show you an example, we're simply going to we're going to set this to be 1. So we're only going to draw 1 triangle. You see that? We're only drawing 1 triangle from that star. And if we were to do 3, then you would see that it draws 3 triangles from the star. But in order to draw the because the main polygon on sides is 5. So it does it while I is less than the total number of sides. So it's drawing triangles on top of each other in such a way. In fact, let me stop it from spinning. I'm going to stop it from spinning by getting rid of this. I'm going to comment this out. So if we stop it from spinning, so here's what it does. So the center of the star is right here in the middle. So first it draws this triangle, basically, right here, and then it will end up drawing the next triangle on top of it, and then then it does the next one. It just overlaps triangles. The point being that SDL geometry renders triangles, but it does it, and then every other shape, including circles, can be made using triangles. So it's kind of it's a little bit weird, honestly. In fact, actually, I have this game is not finished. I have a game that's far from finished, but I first started using a renderer in this game that I'm making. Let me make sure the recording's still working. Okay, yeah, the recording's still on. SDL Chasebox game. Now, here's the thing. This is going to be a very weird game. So, it's going to load some music. Chasebox game. The game where everything is a rectangle. Now, in that last level on that game, you may have noticed the spinning yin yang. Well, here's the thing is there's actually code that does the yin yang. So I have a SDL Chase circle render. So what it actually did is it simulated a circle using a whole bunch of triangles. You can make a circle with enough triangles. So in order to do, it gets the point of a circle. It's the same as the polygon, but it basically uses the circle variables instead. So this this basically does a circle. Yeah, yeah. It's using SDL render geometry. It's using SDL render geometry, and it's actually really cool. But the fact that it draws a circle just using triangles and the SDL render geometry is impressive. Now this one does parts filled. Okay, and this is old code. There's a lot that needs to be changed in this, but this draws a series of triangles, but only up to the main circle slice to use. The idea is that this is what you use if you need to make a half circle. So, for example, let's go to the code. Okay, let's go to the code in this game. Let's find the final level. So, SDL box game. So we need, because there's different levels here. So. And there is something I do need to fix in this as well. So, okay, that's weird. Yeah, so anyway, let's see, which is the one of the yin yang? Okay, let's see here. I'm trying to see where is this one. I'm trying to see where. Okay, where is it doing this? Because I know for sure that I had done this thing where. Oh yeah, yeah. There's where it actually draws the yin yang. But before it does that, it sets things up so the circle the number of circle slices max is 36. But then let's see here. Okay, so for the yin yang, what it does, we're going to go back to the circle render folder. So in order to do the yin yang, so what it does is it sets the number of slices to use to be the maximum number of slices divided by 2. So it draws half circles. So it draws 2 half circles. It modifies the color, draws half a circle, then it rotates it by adding pi. It draws the other half, and then it draws smaller circles, and then just draws filled whole circles that are smaller, and then it does some circles like that. So anyway, yeah, it works. Now this code is old, and there's a lot in the game that could be optimized. For example, for one thing, there is an error in the input system. See, the polling is not supposed to be in the polling for events is in the keyboard function itself, but it's not supposed to be. And because you can run into errors, and some people on the SDF forums had corrected me on this, and so it's kind of weird here. It's something I'll need to fix on my own time, or maybe I could do it here. So here's what we're actually going to do. I'm going to what we're gonna have to do, because I do want to fix this game because it's really messed up. I need to. Okay, so SDL input. So see in this example, you'll see that the input doesn't actually call the polling event. It doesn't. The way this is supposed to work is that okay, so here is what we actually have. Okay, so poll event. So here is what we actually are supposed to do. We're supposed to poll for events and then call the keyboard function if there is an event. We're supposed to use that loop. So let's see here. See, now that I have removed, if I remove the poll event, if I comment this out and I try to relaunch the game, let's see what happens. I'm going to see what happens here, because what actually happened was that it would not let me close the game. The key presses had no effect because we didn't actually poll for events, and then and then I even clicking the X had no effect. So what we need to do now is, in order to fix this, this is what I need to replace. Every time we have the keyboard function called, we're going to have to replace this. So what we're going to do here is I have to go into the box game thing here. Okay, so okay, yeah, here we are. So okay, SDL box game. Okay, so here, okay, see how we have keyboard called several times. Okay, let's do a search for keyboard. There's 13 occurrences for the 13 different levels. So here's what we're gonna do. We're going to do a, actually let's do Control H. We're gonna do a find and replace. So what we're gonna do is every time we have the key, a function that's exactly keyboard. Yeah, there we go. So every time, so we're gonna find it, find. So every occurrence, we're going to replace it with that code. We're going to replace all. Oh, yeah, replace. Okay. Okay, yeah. Okay, so now I'm going to, now that I've done that, we're going to try recompiling the game here. Yeah, it actually, we fixed it because now the, okay, first of all, let me make sure keyboard. Yeah, so there's one. There's another. 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 Okay. This one was accidentally doubled there. We're gonna remove that there. Okay, yeah. Because I accidentally done a replace, then I done a replace all. So yeah, so there should be, okay, yeah, there should only be 13 occurrences. So number 1, we have that. Number 2, number 3, number 4, number 5, number 6, number 7, 8, number 9, number 10, number 11, number 12, number 13. And then we're back at the start. So now I replaced it such that now the keyboard, the polling does not happen in the keyboard function. It's not supposed to. I fixed it. So now, just to make sure it works, I'm going to go ahead and I'm going to recompile and run this game and see if it works as expected. Well, it works as expected. So, as you see, I made some progress in this video because I fixed the input in a Steeplechase box game. Let's see here, and let's see how things are progressing. So, my backups have completed, and then my other video has finished uploading, which is really amazing. So, I'm going to, okay, first of all, I'm going to close this, then I'm going to go to GitHub. And now that I've updated my game, I need to make sure that Chase Box Game is properly updated. So as you see, like, this is sort of behind the scenes programming session. That's what this is. So just to make sure everything's up to date, I'm going to go to Chase Box Game. There it is. So we're going to just select the make file. We're going to select all the header files, even though there was technically only two files that I actually modified. I'm just going to go ahead and make sure everything is up to date here. Totally going to make it up to date. Now, you may notice that some parts of that game were slower than others. It was slower than it needed to be. Now, here's the tricky part. It's not optimized for speed. I was trying to get a game working, but there is something else that kind of slows it down just a little bit. So, if you go into the main file, what you'll notice is that this game does use a surface. And there's a lot of code that depends on the surface, but what it actually does is it also uses a renderer, and only in some of the levels is the renderer actually used. So it creates a software renderer. That actually draws to the surface. So remember I said you need to use a renderer instead of surface? Well, technically you can use a renderer that targets a surface. And the reason for doing so is if you have a lot of code that's already using a surface and certain graphics functions that use a surface, but you want to add rendering functionality to your program, then you could have a renderer that targets the surface. So you can use both in combination, but then you're using software rendering instead of hardware rendering, which is a lot slower. So some parts of this game were a lot slower, and the game is not complete by any stretch of the imagination. But if I was going to do this for production, I would probably have to do a complete rewrite using only the renderer. So that's some things to consider. Oh, and also there is one other thing I wanna do while I'm here. So what I'm gonna do is I'm gonna go to SDL Chase Pong. Okay. So notice how we have this. But I want to try to do something. Okay, I'm gonna try something a little bit weird here. Okay, I'm gonna do something really weird. And what that is gonna be is I'm going to do a few changes here. And now I use a surface, I think. No, I think I may actually be using a renderer. So I'm using a renderer. That's what I'm doing. Okay. So for the draw color of, let's see here. Okay, so the draw color for the screen is currently black. But what if we want to change it to cyan? We're going to make it cyan is what we're going to do. We're going to do green plus blue. So we're going to change the background first. So now it's background because it's meant to be like the color of the sky. So it looks cool. But now let's make the walls that are gray. Let's make them pink instead. So let's go down here before the let's see here where we draw the walls. We're gonna set the render color. We're gonna set this. Yeah. Actually, now this is a fun thing. I'm going to show you something. Before I change the color, I'm going to show you this. There it shows the rectangle that the ball is inside. The ball is a circle using my circle rendering functions, but it's inside a rectangle, and it actually uses the rectangle for collision detection because it's easy. But what I'm going to do is I'm going to comment that back out again, and then we're going to actually, it's probably going to give me a compiler error if I do that. Yep, it doesn't work that way. Yep. Okay, so yeah, first we're going to set it back to the way it was. Then we're going to change the color. We're going to change it to where it's 255. Actually, let me try something. Ooh, that's a nice light pink, but I'm going to just make it plain magenta. Yeah, I haven't changed the graphics code at all, really. I've just changed. I mean, I haven't changed the collision detection. I've changed the yes. So yes, I have changed the the colors. So why did I change the colors though? Well, there's something I have in mind here. So what I'm actually gonna do is okay. So we have so now the circle. Okay, I had done something. So yeah, the main circle is actually yeah, we're using the main circle. Yeah, yeah, that's the initialization code. So what it does is let's see where yeah the main circle is there, and it moves the ball along with the rectangle. So it matches the circle with the rectangle is what it actually does each time. Yeah, but anyway, what I'm going to do is see here how we had here is where it draws the filled circle. It's kind of weird the way it's named one like that. What I'm going to do is instead of calling this function see, because if I comment that out, it's going to not show the ball, but you still see those moving. But now we're going to use the yin yang function. Oh, now isn't that cool? You see how we have the yin yang? We have the spinning yin yang. That is funny. Well, it's not spinning yet. We're going to make the yin yang spin. So now I have to, okay, let's see. Radians. Okay, yeah. Okay, so here's what I need to do. I'm going to, let's see here. I'm going to, first we're going to look at the circle. Okay, yeah, radians, we have that. Yeah. Okay, here's what I'm going to do is I'm going to take from the other example and just make sure I copy the code exactly as it was in this source file. Okay, so radians. Okay, here's what we're going to do. But instead of main polygon.radians, because we don't actually use a circle, yeah. So I'll show you what I'm going to show you what I mean here. What I'm going to do is okay. So after it matches the ball there, so currently it's main polygon.radians, but there is no main polygon because it's just circle in this case. So it's going to be main circle.radians plus equals pi divided by 180. Okay. Yes, it works. It works. So you see how it's spinning clockwise? Well, if we, instead of adding and we subtract, not bad. Really not bad. That's funny. Yeah, that is funny how it does that. I'm going to change it back to clockwise though because I prefer that look. Okay, anyway, as you see, I have modified some code. So now I have my Pong game. I haven't actually added the user input yet. I'm actually not entirely too sure how I would go about that because it would have to be, or will I even add that? Or will I just make the gameplay itself? It's kind of funny how that is. But I think the spinning yin yang adds a little bit of flavor to it. What do you think? Okay. Yeah, that's actually quite funny. It's actually really funny the way this looks. Hmm. Yeah. Oh well. Well, anyway, you get the basic idea. I'm gonna exit that, and I am gonna end this this video here, because now I at least okay, I updated that one game, and now I'm working some on my Pong game. But yeah, so I'm gonna end this video. I hope people enjoyed this because this is a lot of fun to do, even though it's a lot of work.